level 1, we will be simplifying exponential expressions and determining whether a function is an exponential function. So simplifying exponential expressions is review. Here's a couple examples. You're welcome to try these on your own and then just check and see if you got them right. But I will also go through how to do them. So in this first one, I would first raise everything inside the first set of parentheses to the third power. So I would get 2 to the third power, and when we raise a power to another power, we multiply exponents. So that would be a to the 6th, b to the negative 15th. And then I'm going to do the same thing with my second set of parentheses. Everything inside is going to be raised to the second power. So we get negative 3 to the second power, a to the, multiply the exponents, negative 12th. Now I'm going to simplify my 2 to the third and negative 3 squared. 2 to the third is 8, so I get 8, a to the 6th, b to the negative 15th, times, and then negative 3 squared is positive 9, a to the negative 12th. I can multiply the 8 and 9 together, and that makes 72. And then when I multiply a to the 6th times a to the negative 12th, I can add the exponents. And 6 plus negative 12 is negative 6. And b to the negative 15th didn't combine with anything. And then anytime you have a negative exponent, you need to move it. If it's in the top, it needs to move down to the bottom. So I leave the 72 on the top. It's not attached to those variables. It stays up top, and I move a to the negative 6 down, and it becomes a to the positive 6. I move b to the negative 15 down, and it becomes b to the positive 15. And there is my simplified answer with all positive exponents. Okay, next example. For this one, I'm going to simplify a little bit inside first, and it doesn't matter what order you do things. But I'm going to go ahead and simplify the inside first. I'm going to leave the 2 on the top, the 3 on the bottom, and c to the negative 2 and d to the 4th are both on the top right now. C to the negative 2 needs to move down to the bottom, and it will become c to the positive 2. D to the 4th stays on the top because it has a positive exponent. And then if you raise anything to a negative power, you can flip it. Raising something to the negative 1, you can just flip the whole fraction or take the reciprocal. Everything on the top is going to move down, and everything on the bottom is going to move up, and then it's going to be raised to the positive 1 power. And you can do that anytime you have a negative exponent on the outside. So I'm going to move 3c squared up to the top, 2d to the 4th down to the bottom, and that's to the positive 1 now because I flipped it. Of course, I don't have to write to the positive 1, so my final answer would just be 3c squared over 2d to the 4th. That can't be simplified. In the next example, there's different orders that you can do things. You can simplify each part separately and then multiply them together. You could get it all into one fraction and then simplify. It's up to you. I think I'm going to simplify each fraction separately. So starting with the first fraction right here, I'm going to leave the 4 on the top, and then whenever you have the same base, you can subtract exponents. So if I'm doing e to the 6th x over e to the 2x, I can subtract those exponents. 6x minus 2x would be e to the 4x. And then the next part over here, my e to the negative 3x, I can move that down to the bottom, and it would be 1 over 2e to the positive 3x. And I could think of this as one big fraction where I just have 4e to the 4x on the top and 2e to the 3x on the bottom. And then I would simplify this. So 4 over 2 is 2 on the top. And then again, subtract the exponents for my e's because they have the same base. 4x minus 3x is 1x, so I get 2e to the 1x, or just 2e to the x, as my final answer. The other part of level 2 is determining whether or not a function is an exponential function. So what is an exponential function? A function in exponential form with the base will always be a fixed number or a constant. So the base is a constant or a fixed number. And that base could be a fraction, it could be a decimal, it could be a whole number, but it's a number. And then the exponent is the variable. Okay, so looking at these examples down here, this very first function, 2 to the x, that is a very typical exponential function. So that's yes, exponential. The base is 2, a fixed number. The exponent is a variable, x. Part B is not an exponential function. That's a polynomial function, or a quadratic polynomial. So that's the unit we just completed, where in polynomials you have variables that are raised to whole number powers. The next part is an exponential function because we have a constant raised to a variable exponent, so that's yes. It could have a number multiplied in the front. It can have numbers that are added or subtracted, like it might have a +2 on the end. But as long as your variable is in the exponent and your base is some fixed number, it's an exponential function. In part D, that's a yes. It's okay for your base to be a fraction. It's still a fixed number. The variable's still in the exponent, so that's exponential. Part E is still yes. So the variable's in the exponent. We have more going on than just an x. We have a negative 2x, so that involves a transformation, but it's still an exponential function. And this last one would be a no. Whenever you have the two polynomials being divided, or the quotient of two polynomials, we call that a rational function. And we haven't gotten to that unit yet.